As the threat environment changes in the world we live, so must the tools we use. To help manage your response to these changing threats, we're going to cover the proper use and operation of a very powerful tool, the Hazmat CAD, short for Hazardous Material Chemical Agent Detector, that uses surface acoustic wave sensor arrays for the detection of nerve and blister agents, offering excellent selectivity, being designed to limit false negatives or false positives. The Hazmat CAD Plus also uses electrochemical cells to detect blood, choking, or toxic industrial compounds with time-proven sensors. This unique combination of both SAW and electrochemical technology provides a comprehensive solution for chemicals likely to be found in a hazardous material emergency. Hazmat CAD series detectors are capable of detecting the following threats: nerve agents such as VX, GA, GB, GD, GF, and dirty VX; blister agents such as HD and HN3; blood agents such as hydrogen cyanide; choking agents such as phosgene; and toxic select industrial chemicals by chemical class identification such as halogens, chlorine and bromine, and hydride gases, arsine, phosphine, and diborane. Hazmat CAD series detectors are available in 3 different configurations: Hazmat CAD, which detects nerve and blister agents; Hazmat CAD with a single electrochemical sensor, which detects nerve and blister agents plus blood or choke agents; and Hazmat CAD Plus, which detects nerve and blister agents, blood and choke agents, as well as hydride, halogen, and blood chemicals. Having just one instrument capable of detecting so many compounds means carrying fewer instruments and being more effective, because you have the right detector right away. No more fumbling or guessing, having to reach for a chlorine detector if you think chlorine is present, or an arsine detector for arsine, or even a chemical warfare detector if you think a chemical agent has been released. The Hazmat CAD monitors offer a reliable and simple tool for gas monitoring and are designed to identify many threat chemicals in an unknown environment. The Hazmat CAD detector's state-of-the-art technology uses advanced problem-solving software capabilities in a system that does not require complex user operation. We heard the message loud and clear. Keep it simple. And Hazmat CAD series is just that, simple to use. Let's start with the Hazmat CAD's basic operation. The Hazmat CAD has a 3-position sample port slide cover. The open position provides for direct access to the sample inlet. The closed position secures the sample inlet. Hazmat CAD should be stored with the sample inlet in the closed position. The 3rd position, the dust filter, works with the sample pathway and is designed to help prevent particulate matter and water from entering the sample inlet. The Hazmat CAD detector has 4 push-button keys, on and an off button for power. The alarm silence button deactivates the alarm horn during a single alarm analysis. It will sound again on the next analysis if the concentration remains at the alarm value. For example, when a high G alarm sounds, the operator silences the alarm. The horn will sound again when the concentration level changes to a medium G or a low G. To silence the alarm for quiet operation, you must be in a non-alarm situation. Pressing the alarm button once shows Alarm On. Pressing the alarm button again quickly cycles to the Alarm Off setting. This completely quiets the alarm. Turning the unit off, then back on, resets the Hazmat CAD to the default Alarm On setting. The Mode Select button selects between the 2 modes of operation: fast sensitivity or high sensitivity, plus a training mode configuration. The fast mode is a 20-second response with sensitivity levels as found in our published data sheets. The high sensitivity mode is a 120-second response mode for additional sensitivity. The analysis mode can be checked at any time by pressing the Mode Select button. Press the button twice to change the mode of operation. The operator can verify the mode at any time and not interrupt the sample analysis. To energize Hazmat CAD, press the On button. During startup, the green System OK light will flash. The LED displays the test screen, remaining battery power, and mode of operation. Fast mode is the default mode. Once the green System OK light flashes, HazmatCAD is ready for operation. Within the first 30 seconds, the system will automatically perform a self-diagnostic check, purge its sampling system, and begin analyzing ambient air for trace levels of chemical compounds. If turned on in a known clear area, the green all clear light will come on. The HazmatCAD CWA SAW sensor array runs on a 20-second analysis cycle. During this time, the sample is collected on an absorbent media and desorbed into the sensor array. This process continues every 20 seconds until you turn the instrument off. In HazmatCADs that have only the single electrochemical cell using either HCN blood or COCl2 choke, the sensor is part of the SAW sensor array flow path. Those alarms will report blood or choke agents as tox on the display. The electrochemical cell is located inside the battery door compartment. In the HazmatCAD Plus, the electrochemical sensor array operates in parallel to the SAW sensor array, so there are two sample inlets. The electrochemical sensor array operates on a real-time basis, having its own flow system. Essentially, this is two instruments in one, using Fusion software to provide the data on the LED display. A great deal of thought went into designing the HazmatCAD detector ergonomics. We have oversized buttons that are simple to actuate while wearing bulky gloves. Additionally, there is easy-to-read lettering and a super bright LED display that is visible even under the brightest light conditions. The HazmatCAD has a top display panel providing redundant alarm, System OK, and low battery indications, which allows the display to be viewed when using the belt clip. To verify proper operation, HazmatCAD has a simulant check source designed to fully test the SAW sensor array. MSA recommends that an operational verification is performed prior to use and at least every 3 to 6 months to ensure operational readiness. To use the check source, place the inlet position to open, located at the SAW sample inlet. The SAW sample inlet is to the left when the front of the instrument is facing you. If equipped, the inlet to the right or closer to the top display panel samples the air for the electrochemical cell array. Remove the vinyl end caps on the check source. Hold the check source to the sample inlet for 2 to 3 seconds. The HazmatCAD will display a G alarm and its relative concentration. Depending on the stage of the 20-second cycle, this could take up to 40 seconds to respond. When the sensor array is working properly, the G alarm yields the pattern response that verifies the proper operation of all sensors. Continue running the HazmatCAD until the instrument reports all clear. Additionally, to verify their operation, you can bump check the electrochemical sensors using compressed gas cylinders. Upon completion of the SAW sensor bump check, replace the vinyl caps on the simulant check source to maximize its life. To activate the training mode, turn on the HazmatCAD. When you see the mode information, press and hold the Mode Select button until you hear multiple beeps. These tones indicate the HazmatCAD is now in the training mode. The beeps repeat frequently to remind you the unit is in training mode. In training mode, the software is able to detect a wide variety of volatile chemicals. The HazmatCAD may report a G or H alarm. When using an alcohol simulant, the instrument will report a G alarm. Using a hydrocarbon fuel, an H alarm. To return to the normal operation, turn the unit off and then back on. Let's look at the various readouts. The HazmatCAD detector indicates the presence of a chemical agent or toxic gas by sounding an audible alarm, flashing the red alarm lights found on the front panel and on top display, while displaying one of the following alarm classifications: G for a nerve agent, H for a blister agent, TOX for choking or blood agents. The HazmatCAD Plus reports chemical agents exactly as the HazmatCAD. The Plus uses a 4-sensor array and reports the information as HYDR for hydride gases. HALO for halogen gases, or BLOD for blood agents, as well as hydrogen cyanide, and CHOK for phosgene gases. One of the following relative alarm concentrations will also be displayed: high, medium, or low. The alarm status LEDs will flash at a rate that is related to the alarm level. For example, a low-level alarm will flash slower than a high-level alarm. The green SysOK light indicates proper electrical operation of the instrument. The green all-clear light indicates no threat vapors are present. The yellow low battery light indicates the battery power is getting low. HazmatCAD has a battery compartment located at its base. By gently squeezing on the sides of the base and pulling it away, the compartment door will release. HazmatCAD can hold two NP550 Sony lithium-ion batteries. One battery will power HazmatCAD for 4 to 6 hours, depending on the mode of operation. Two batteries can be used to obtain maximum mission life of 8 to 12 hours. HazmatCAD comes with an external battery recharger for the lithium-ion batteries. When a battery is properly charging, the green LED on the charger will be illuminated. The typical charge for a Sony NP550 battery is approximately 1 hour. HazmatCAD has an internal data log that records alarm events and fault, each with a time-date stamp. The data log format is located in the operator's manual. HazmatCAD has available various accessories and options. As an option, HazmatCAD has an infrared communication port located on the top display panel. This port allows the wireless transmission of the internal data log. This feature requires a personal computer configured to use an infrared interface port and a compatible software program. The infrared port and the software are available from MSA. The infrared receiver must be hardwired at 9600 baud to receive data from HazmatCAD. If you enable IR communication, the normal RS-232C port on the battery door will not function. The standard RS-232C communication port is located on the rear of the battery compartment. HazmatCAD comes with a cable using a DB9 connector, which will connect to the PC serial port. Either the infrared or the RS-232C communication port can download HazmatCAD's data log information. HazmatCAD data log reports only alarm conditions using a time-date stamp, concentration, and associated signal value. HazmatCAD has a protective rubber boot that is designed to provide protection from incidental damage. The boot is designed to pass a 3-foot drop test. The boot is removable and should be discarded and replaced if the instrument has been exposed to a hazardous chemical. HazmatCAD and all its accessories can be stored and transported in this custom hardshell case. Remember, to use and train with the HazmatCAD, no radioactive source, no calibration, and no consumable filters are needed. Remember to read all instructions, labels, and literature that come with your product. Only they contain complete information about the HazmatCAD and HazmatCAD Plus detectors. The next time you are at a scene like this with the possibility of a chemical release, use the HazmatCAD to assist you in quickly determining the best course of action.